standard, you could say. Then this is the improvement that is widely used, adding in something called momentum to avoid the zigzag that we're going to see over there. And there's another way to do it. There's a Russian guy named Nesterov. His papers are not easy to read, but they've got serious content. And one thing he did was find an alternative to momentum that also accelerated the descent. So these both produce faster descent than the ordinary one. Okay, and then you know, looking ahead, that for problems of machine learning, they're so large that the gradient, we have so many variables, all those weights are variables, and that could, hundreds of thousands is not uncommon. So then the gradient becomes a pretty big calculation, and we don't have to do it all at once. We don't have to change. So xk is a vector of all the weights, and our equations are the matching the training data. So we don't have to use all the training data at once, and we don't. We take a batch of training data, like one, but that's sort of inefficient in the opposite direction, to do them one at a time. So we don't want to do them one at a time, but we don't want to do all million at a time. So the compromise is a mini batch. So stochastic gradient descent does a mini batch at a time. A mini